Holy cow. A teacher is buying word games and board games for his students. Oh, what a nice teacher. We do great things. Each word game can be played by up to 4 students. Each board game can be played by up to 2 students. The teacher needs enough games for 30 students to play at the same time. The maximum amount that the teacher can spend on the games is $200. Holy cow, teachers. We don't get paid enough for that. The number of word games X and the number of board games Y the teacher must or buys must satisfy the system of linear inequalities below. Oh, okay, so this isn't too bad. I mean, it's not good, but all of this information is already thrown into this system of inequalities right here. The teacher plans to buy 5 word games and 8 board games. Which statement about the number of games the teacher plans to buy is true? All right, so before I even look at these, let's try to figure stuff out. All right, let's try to figure stuff out. Basically, this equation is like, remember, this is how many kids can play these types of games, and I need enough games for 30 kids. This is how much teacher is spending. I can't spend more than $200. So if it's going to give me these parameters, 5 word games and 8 board games, let's try to figure out each situation and try to answer questions about each situation before I even look at my options. Word games were given to us by X, okay? Word games are X. So 4 times X in this case is going to be 5, plus 2 times Y in this case is going to be 8, has to be greater than or equal to 30. 20 plus 16. 36 is greater than or equal to 30. So basically what this part is saying is if I get, or if teacher gets 5 word games and 8 board games, that's enough games to make 36 kids happy, and I need to make sure it's more than 30. So check number 1, I guess. So do I have enough games for everybody? Yes. Thing number 2 is, am I spending too much money? So 14.5 times X, which is word games, which is 5, plus 18 times 8 must be less than or equal to 20 or 200, and I have to find out if that's a true statement or not. So 14.5 times 5 is 72.5. 18 times 8 is 144. That's got to be less than 200. This one's definitely not going to work out because 72.5 plus 144 is going to be $216.50. And $260.50 is not below 200. So this guy doesn't work out. So what we have here is if this teacher gets exactly this amount of games, 5 word, 8 board, she has enough for 30 people, but is spending way too much money. So there will be enough games for 30 students to play at the same time, but the total cost will be greater than the maximum amount. There you have it. Let's just double check. There will be enough games for 30. Yep. And the total cost will be less than the maximum amount. Nope. There will not be nope, and there will not nope. Okay? So there you have it. Now, you could probably figure this information out without these, like if you kind of use common sense a little bit. But, this helps, I guess, for all of you mathy people. Fun problem. Big problem.